Okay, guys, I was saying just before we got started about margin of error that the closer we get to surveying everybody, the less margin there is for error, right? That means that if I want to know what, if you're voting for one person over another, and I poll everybody in this room, I could with certainty say who would win the election if it was just this room voting, right? Because I polled everybody. But if I only poll half of you, then my margin for error is going to go up a bit, right? I may be off a little bit because I'm not polling everyone. Although it may be representative, it may not be exactly right because I'm not taking everybody into account. The other half may fall toward the other candidate, okay? So we give things called margins of error. And a margin of error often looks something like this. It has plus with the minus sign. Plus or minus 2%, or plus or minus 3%, meaning that the numbers that I give you might vary as much as 3% higher or 3% lower. Okay? So let's look at this first example. It says, in a survey of 5,000 randomly selected households, okay? So they picked 5,000 households randomly. 460 households watched a certain program. Of the 105 million American households, about how many watched the program? Okay, I'm sorry guys, I introduced you to margin of error, but this first example is not really talking about it. But we'll talk about margin of error in one of the other examples as soon as we get there. I thought it was in this one, but it's not. Okay, we'll bring up, I sort of explained it, but we'll talk about it later in a different example. All right, so for this one, if we get 460 out of 5,000, do you see how I'm writing this? Can anyone finish how I would write this? What do you think back there, Teddy?
Then you put equals.
Equals.
X over 105 million.
X over 105. You know what? I don't even have to say million. I can just remember that this is 105 million. So this will be in millions too. I can say million if I want, right? And just not think about it anymore. And I can do that.
Yeah.
All right? You guys have your calculators. We're going to cross multiply. We're going to get 5,000x is equal to, someone tell me what 460 times 105 million is. But you know what? It's going to give you probably something with scientific notation. Did it? No? What did it give you, Simon?
Oh wait, never mind.
Someone do 460 times 105. Tut?
Times 160.
No. 460 times 105. What'd you get, Alex?
40,300.
Like this? 40,300?
No, 48.
48,300? But then it's millions, right?
Yeah.
Okay. So then I'm going to divide by 5,000 on both sides. And remember, I can always cancel out terminal zeros. So someone now, x is equal to 48,300,000 all over 5. Can someone divide that for me and tell me what that is? X is going to equal, what do I get there? Oh, Justin's got it. Justin, what you got?
I got 96,000. No wait. 9 million.
Yep.
660,000.
660,000. 9,660,000. Okay. So if 460 households out of 5,000 wanted what? What do they like? What do they want? They watched a certain program. Okay. Then out of the entire country of households, 105 million households, we'd expect 9,660,000 to be watching that program. Now going back to margin of error, do I think it's going to be exactly that?
No.
No. I mean, I only chose 5,000 households, and there are 105 million of them. Okay? So there's going to be a margin of error to some degree. But it's probably going to be somewhere around that. Okay? The more randomly chosen houses we survey, the closer we'll get to the actual number. All right, good job. Let's